Hey everyone, welcome back. In this video we will take a look at how to make the turned component parts of the Mepps Black Fury number 5, my personal favorite fishing lure. Since Mepps does such a good job on their lures, we will save the final assembly for another future video where we'll make a custom variant. For this video we will focus on making the 4 turned parts featured on the Black Fury. There's the body, 1 bead, and 2 cones. First, let's measure the dimensions of each of these tiny little subcomponents. We'll use these dimensions to reconstruct the parts in CAD or on a napkin sketch if you prefer to do that instead. Next, we need to come up with a cutting strategy for the parts. We're going to write our G-code manually, which is very easy to do with a little bit of planning. Our parts will only use G1 straight line moves and G3 counterclockwise arcs. Now for the larva-inspired blob body shape, we'll need to use some 3/8 bar stock. The issue I see here is we don't want to take too deep of a cut with our carbide tooling, so we should take some straight line cuts to approximate the blobby shape first. Then we can let the round profiling cutter do its job in one epic roughing/finishing combo pass. Now for the bead, the bar stock is 1/8 inch OD. Since it's tiny, we can try to just let the round profiling tool cut the profile in one pass. We can change our feed override on the fly so we get a good cut. For the single cone, we have a 1/4 inch OD bar stock, so again, we'll eliminate the excess material with some straight line roughing passes. Then our cutter can finish the profile using G1 straight line moves. Finally, we have the double cone. The bar stock here is 3/16 of an inch for this part, and the bead itself has starting and ending ODs large enough for us to slowly cut the profile one pass. This is our insect larva blob shape modeled in 3D CAD. Since we're using a 30 thou round cutting tool, I've added this little offset line. And from the CAD we create this nice 2D drawing. Finally, we use the 2D drawing to manually write the G-code. This happens to be the Beryllium control software, which is super simple to use. We are able to write the G-code using only G1 straight line moves and G3 arcs. You'll notice there is no G-code header required for this controller. Also, text inside the parentheses are called comments and are not executed by the hardware. For the G3 arcs, it is very important to use 4 decimal places so the motion controller can resolve the arcs without throwing a math error. Here's the bead, and similar to the prior part, we're using a round profiling tool. So I've offset the arc so we achieve the proper OD. Then I use the 2D drawing to make life simple when writing the G-code. Same as last time, we use 4 decimal places on the G3 arc to avoid a motion control error. And now you sort of know the drill on doing 3D models and then using them to create 2D drawings and then G-code. And this little cone is kind of cool looking. It looks like a space capsule or something. You'll notice in this G-code, every single code happens to be a G1 straight line move. And that's the beauty of the Beryllium lathe controllers. You could get away in some cases with only knowing G1 and no other G-codes. Finally, the last little part is this double cone. It's tiny. We're just going to cut it with straight line moves and use the feed override to get the finish we want. Now that we have our G-code, we need to put it in a little flash drive, take it over to the machine, put it in the machine, and I like to post a drawing next to my machine so I can keep an eye on the theoretical dimensions. Select our bar stock from the bar stock organizer. Now we load up our mini lathe and get going. So we're going to start by taking a little zero cut, then we're going to run the part, and this is done with that rounded profiling tool. That's the VG125-030-002-L260-U. Super useful tool. And there it is. There's the little bead. Now that we've got all of the roundy profile stuff done, we're going to switch to the Style 1 VersaGroove cutter, and that's going to be more for our straight line moves. So to install the VersaGroove tool, you've just got to get at these two little hex set screws on the side of the tool holder, and you can tighten them down. You don't have to go nuts. If you do, you're not going to break that carbide. I've never broken any part of the shank of that tool ever. Let's run that single cone. We'll just take our zero cut and then drill it and then run the profile with the cycle start. You can see as this VersaGroove cutter is going across the profile, there's really no chatter or flex. Everything looks really solid on this, and obviously it's because we're using brass. It's free machining brass. It's the best possible scenario for this cutter, but it's working out so well. It's really unbelievable. Final part is this little double cone, and what I did here was backed off the feed, so I did a feed override of took it down to 50% or so, and that allowed it to take its time hogging out that material. It's sort of out of the bounds of the VersaGroove cutter because we're hogging a lot of material, but if you back the feed rate way down and you take your chances, it can work out pretty well for you. The length to width ratio on this particular cutter, something like 8.6, which is just nuts. And there's our last little part. Look at that. So here's our batch of Black Fury parts, and seeing these together, especially coming off the mini lathe, really gets my creativity amped up. I can't wait to take my favorite fishing lure to the next level someday soon. I've got all kinds of ideas for other body shapes and tail material for the hook. So stay tuned. Adios.